Good afternoon, ma'am, sir. Good afternoon, everyone. The title of this study is Internet of Things-Based Solar Tracker Streetlight with Scott and Afara Coarctata Eliminator. For the background of the study, in recent times, there are numerous places that are using solar streetlights, and it is widely used because of its important benefits. But the energy that has the solar panel is only limited. Therefore, finding ways to extensively get the energy from the sun is needed. The addition of Scott and Afara Coarctata or Blockbug Eliminator is also a help to reduce the inconvenience it can cause to some urban and rural areas. The grounds of this study is to create a prototype of an Internet of Things-based solar tracker with Scott and Afara Coarctata Eliminator, whereas the solar tracker will track the position of the sun above the sky, and therefore the solar panel will receive a large amount of energy. The addition of Scott and Afara Coarctata Eliminator will help the rate of efficiency and advancement of the prototype, whereas the Blockbug Eliminator will trap the Scott and Afara or the Blockbug to lessen their inconvenience at a specific place. The use of solar panel in the streetlight is to get rid of immense use of electricity. As you can see, our project is a streetlight that is composed of the use of solar panel, Blockbug Eliminator, and the IoT-based solar tracker. But the main component of this study is the IoT-based solar tracker. The idea of adding the Blockbug Eliminator is to make this study more efficient and at the same time unique. The main goal of this project is to design a very precise solar tracker and share the information through Internet of Things. In this work, the tracker will sense the sun's position.
The study aims to design and develop an Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator. Specifically, this study aims to do the following. First, design an Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator. Our goal is to increase the efficiency of the prototype in harvesting solar energy by using a solar tracker. Second, construct a prototype of an Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator. Third, test the functionality of Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator. Internet of Things will be implemented in our prototype, which enables the user to control and manipulate the prototype with the use of the Internet. And lastly, evaluate the adaptability of the Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator.
SOP1. Design an Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Eliminator. We, the researchers, came up with an idea to build a prototype in which we can make use of the solar tracker, and at the same time, it can also function as a bug eliminator.
Statement of the problem number 2. This study aims to construct a prototype of an Internet of Things-based solar tracker streetlight with Scott and Afara Coarctata Blockbug Eliminator. In this statement, we are to construct a prototype of our study to test the functionality of its design.
Statement of the problem number 3. Test the functionality of Internet of Things or IoT-based solar tracker streetlight with Scott and Afara Coarctata or Blockbug Eliminator. One of the goals of the study is to see if the prototype is working properly. To test its functionality, we will place the prototype in our chosen area, which is rice fields, for us to know if the prototype we made is working its job. Especially in the bug eliminator, we need to make sure that the eliminator really eliminates the bug if it go near the streetlight.
In our fourth statement of the problem, we address to assess if our study will be beneficial to our chosen scope and limitations. We will evaluate if the Internet of Things-based solar tracker streetlight with a Blockbug Eliminator will be advantageous to the community through conducting a survey in the local area.
I will now be explaining about the significance of the study. Our study is greatly beneficial to the following. First are the farmers. The health of crops, especially those in rice fields, are at risk whenever black bugs are rampant. Farmers can reduce the infestation of black bugs with the help of a solar panel that can control a black bug eliminator. Through this, farmers are able to keep their crops healthy and away from the possibility of failure. Second are rural areas and areas prone to black bug infestation. With the help of an IoT-based solar tracker streetlight with black bug eliminator, locals can not only conserve energy, but they can also have light and decrease the numbers of black bugs present within the area. Third are travelers. It is very risky to travel at night. Therefore, we need light to guide our path. With the help of a solar tracker streetlight that can detect physical movement, it can provide light to passerbys and can also conserve energy. Next are computer engineering students and other related engineering courses. This study can help engineering students to gain more knowledge about the Internet of Things or IoT-based solar tracker streetlight with black bug eliminator and its background and usefulness. Next are the researchers. Through the conduct of the study, the researchers may gain new knowledge and new insights on how the new technology works, such as the Internet of Things or IoT. Lastly, the future researchers. Future researchers can gain new knowledge and new insights about how Internet of Things or IoT really works, and they are able to dig deeper into this type of new technology.
Assembling the prototype. The prototype is assembled in which all parts may be able to function to the best of their abilities. The solar tracker is placed on top of the streetlight so that there would be enough room to rotate and follow the direction that the sun may move. The ESP microcontroller is placed beneath it so that it may provide control for both the solar tracker and the eliminator. The prototype is connected to the streetlight, the solar tracker, and the eliminator, in which the tracker would provide power for the light and the eliminator. The eliminator is placed just below the prototype in a location where bugs may gather. The prototype is interconnected and would be accessible through IoT. Through this procedure, we may be able to assemble our prototype. Adjustments and changes will also be made in case we encounter problems or opportunities that may furthermore strengthen and enhance the capability and usefulness of our prototype.
For the formulation of program logic, since codes are necessary to make this project more functional, we the researchers will buy ESP 8266 microcontroller to use as a device where we will put the codes.
Building the Scitinofara quartata or black bug eliminator. The eliminator is composed of disclosed embodiments that will include a processor and a system for an organic insect extermination lamp that traps and kills black bugs continuously without the use of toxic chemicals and pesticides. The prototype contains an organic insect extermination lamp, a fixture containing a power source, and a LED light source for attracting. Without producing significant heat, black bugs will be trapped in at least one enclosed reservoir with a closable cap to hold a natural exterminating substance. Essentially, this eliminator is a system attached to our prototype which supplements its overall function and could possibly help residents manage the pests in their locality.
In order to evaluate the functionality and adaptability of the prototype, the researchers will use both empirical method and survey questionnaires in order to gather significant information. Addressing the researchers' SOP3, which is to test the functionality of the Internet of Things or IoT-based solar tracker streetlight with Scotinofara coarctata black bug eliminator, the researchers will perform 2 trials to prove that the system is indeed functional. The first trial is to test the functionality of the IoT, solar tracker, sensors, and microcontroller to evaluate the capability of the prototype as a streetlight. The second trial is to test the functionality of the Scotinofara coarctata black bug eliminator to evaluate the capability of the prototype in capturing black bugs. The researchers have adapted this method from a previous research entitled Internet of Things IoT-based Home System Appliance Controller, who used the same kind of approach in testing the functionality of their prototype, which means that the researchers will perform two trials to prove two aspects or key features of the prototype. The researchers have decided to do so because they want to emphasize and focus on those two main aspects to strictly monitor if those aspects are properly working or not.